It was hundreds of years ago that animals discovered that there were ways of making musical sounds. They maybe first used their voices, but soon they discovered they could make musical sounds by plucking a stretched string or by blowing through hollow pipe. But our early musicians soon found that not every note sounded good with every other note. In fact, some combinations sounded quite unpleasant. Why? The question of why some sounds work together and some don't caught the attention of many of the preeminent scientists for many centuries. It was the stretched string that offered the best clues. The Boffins observed that strings whose lengths were mathematically related seemed to sound more logical or tuneful together. For example, two strings, one of them twice as long as the other, sound very good together. So do two strings where the longer one is 1.5 times the shorter, and 1 1/3 times, and 1 1/4 times. You may have noticed that these string lengths equate to very simple numerical ratios using whole numbers. And this discovery defined music for centuries, and still does. The 2:1 ratio is what we call an octave. The 3:2 ratio is what we call a perfect fifth. The 4:3 ratio we call a perfect fourth. 4/5 is a major third, and 6/5 is a minor third. Our musical scientist or musoscientist built a group of pitches that work together, and by playing them one after the other, they created the worst nightmare for every young musician. The scale. Music all over the world started out based on these pure numerical ratios. But then, why does music from Japan or Indian music sound slightly odd to our ears? Well, that is because even the purest numerical relationships can get a bit fruity if you push them too hard. And getting them back into alignment requires something called temperament.